So we'll start from the mix and yield variance. So this question was asked in December 2015 question paper for ACCA, and this is about the question here. So required, calculate the total material mix variance and the total material yield variance for OBC for the last quarter, and this has a 7 marks, and you have to tell using the information in the question, suggest 3 possible reasons why an adverse material yield variance could arise on at OBC. Okay, so you have to tell 3 reasons why adverse material yield variance will occur for this company. Okay, so first we'll get an idea about what these variances are. So material variances are of 2 types. So you have price variance and usage variance. The usage variance can be further split into mix and yield variance. Okay, so mix and yield variance are useful only when a product is produced using several inputs, okay, several raw materials, and this raw material proportion can be changed. Okay, so for example, when you produce a soap, there are like 3 ingredients or something, like the soap base or the fragrance, okay, or the foaming, okay, something like that, or a chemical X or something. So you have the power to control the mix of the proportion in which the raw materials goes inside to the production. So in that case, when the material mix changes, that will lead to some kind of a new different variance. Okay, so we are trying to find out any adverse or favorable variance that occurs because of the change in the proportionate mix. Okay, so there's always a standard mix, and when compared to that, what is the actual mix, and if there's any difference between them, and is that difference positive or negative. So thereafter we have another variance which is called as yield variance. So because the inputs are going to be different from what is the standard input, will it result in a different output. Okay, so for example, you use a high quality raw material. Because of using a high quality raw material, you are getting a higher output. Okay, so that is a standard mix, but what you are doing is you are using a lower quality raw material, and you're changing the proportion of input. Because of the change in proportion of input and the lower quality material, that leads to the output being different. Okay, so because of your input is different, is the output different or not? So that is what we are trying to find out through material yield variance. Okay, so hope you got the idea. So the sum is like quite straightforward. So we'll start from material mix variance. The material mix variance formula is this: material mix variance equals to, see, it's almost the same as usage variance only. So if you take usage variance, see what it is: SP into SQ minus AQ. Here it is SP into RSQ minus AQ. So only the RSQ is the different part. Okay, so it is not standard quantity, it is something new. What is this RSQ? See, RSQ is called as revised standard quantity. So we will mention it here. It is called as revised standard quantity. Okay, so that is called as RSQ. So what is the formula here? Formula is something called as TAQ by TSQ into SQI. So TAQ is total quantity of actual mix divided by total quantity of standard mix into standard quantity of each material. Okay, so when we do a sum, it's like quite easy. When you look at from here, it is like quite tough. Okay, so let's start with this question. So we have already read the required. So we'll start from the question. So the organic bread company makes a range of breads for sale to the sale direct to the public. The production process begins with workers weighing out ingredients on electronic scales and then placing them in a machine for mixing. A worker then manually removes the mix from the machine and shapes it into the loaves by hand, after which the bread is then placed into the oven for baking. Why is he giving so much of stories? Is because for the second part, the third 3 marks, okay, why is the yield different? Okay, So that's why he is giving all this baking and cooking class stories and all he's telling us. All baked loaves are then inspected by OBC's quality inspector before they are packaged up and made ready for sale. Any loaves which fail the inspection are donated to a local food bank. So we'll see the theory question later. What is our consideration is these numbers. Okay, with numbers only we can do the problem. So the standard cost card for OBC's mixed bloomer, one of its most popular loaves, is as follows. So you have three kinds of ingredient: white flour, whole grain flour, yeast. Okay, so 450 grams at 1.8 per kg, 150 grams at 2.2 per kg, 10 grams at $20 per kg. Okay, so this is the quantity they are buying. Okay, they require to produce one bread, and one bread will weigh around 610 grams. Okay, when you buy in kgs, this is the price for it. So proportionately 450 into 1.8 will proportionately give you this 0.81. Okay, so you can try that. So 450 grams means, okay, 450 grams means like 1000 grams is a kg. Okay, 1000 grams is a kg. So you have to work out like this: 450, okay, into 1.8. This 1.8 is for how many grams? Is for 1 kg or 1000 grams. So you have to divide 1.8 divided by 1000. Okay, that would be a much better thing. Okay, you will get this answer 0.81. But we don't want that and all. So when we add, this is the standard cost of the raw materials. So that also he has given. Thereafter he tells budgeted production of mixed bloomers was 1000 units for the quarter. Okay, so they thought of producing 1000 units, although actual production was only 950 units. So they have produced only 950 units. The total actual quantities used and their actual costs were as this number. So totally they have bought all the raw materials in kgs like this, and per kg price, okay, per kg price is like this. So this part of the number and this part of the number would be same. See, white flour is 1.8, here it is 1.9, here whole grain flour is 2.2, it is 2.1, yeast is 20, here it is 20. Okay, but this is for 950 breads. Okay, they are using this much of kgs. So what is our first consideration? Our first consideration is whether the standard mix, okay, and the actual mix, are they differing or not. Okay, so how do we find out? It's very easy. Once you put it into the formula, it will directly give you an answer. Okay, so we'll start. So we'll start with RSQ. So RSQ is TAQ by TSQ. So we have to first get these numbers: TAQ, total actual quantity, and TSQ. So that both you have to get. So total actual quantity that we are using, okay, that we have used is 570.5 kg, and the total standard quantity for per bread, this is for per bread, it is 610 grams. So 0.61 kg. This is also kg only. Okay, so 0.61 kg is per bread. Okay, so what do we do here is we are trying to find out a revised standard quantity. Okay, so our formula is TAQ 570.5, right, divided by TSQ. So TSQ is 0.61 into, okay, into the standard quantity of mix. The standard quantity of the mix is 450 grams. So we can put it as 0.45 grams. So we'll get the answer. So similarly to that, we have to find out this. See, the TAQ will not change, TSQ will not change. What will change is the SQ. Okay, SQI, the last one, that alone will change. So this will be 150 grams. So 150 grams will be 1.15, and last is 10 grams. So if you see, 10 grams should be should be having a place like 0.1. Okay, 0.1, 0.01 grams. Okay, if you don't know how to convert grams, no problem. 10 divided by 1000 grams is a kg. 1000 grams is a kg. So just divide like this and you will get the gram. See, 0.01. Okay, so that's about it. Let's get the answer here. So we got the answer here. So what about the metal mix variance? Okay, so we'll start from white floor. So white floor is, what's the formula? See, SP, standard price. So standard price is 1.8 per kg into RSQ minus AQ. RSQ is 420.86 minus AQ. Actual quantity as this 408.5. So that's done. So let's get the second one. See, second one is again, what is the standard price? Standard price is 2.2 into 2.2 into RSQ. RSQ is 140.287 minus 152. So that's also done. So the last one is SP. Standard price is $20 per kg into RSQ, which is 25.74 minus AQ. So actual quantity is 10. Okay, I think something is wrong here. Okay, 1 second. I think we got the number here wrong. So we'll recalculate that alone. Okay, it's 9.35. I think we did something wrong. Oh my god. We have to fully do it. SP is SP is 20 into RSQ, which is 9.35 minus AQ. Actual quantity is 10. So close the bracket. We'll get the answer now. So let's get the answer. So put together, all these three things will lead to the variance. Okay, it is a -1, so it is a adverse variance. It is a adverse variance. Okay, so the next one is yield variance. Okay, so what is yield variance? So I think first we'll discuss about metal mix variance. See, metal mix variance tells you that, see, look at here. This RSQ is a revised standard quantity. Okay, so there is a total input that has been put 570, but that 570 kg is split as per the standard proportion. The standard proportion is this number 0.45 divided by 0.61, 0.15 divided by 0.61, 0.01 divided by 0.61. So that is the standard proportion. So the total actual quantity is revised in terms of the standard proportion. So we got the standard proportion here. So this is a revised standard quantity. Okay, and how that differs from the actual quantity. So if you see, they should have used 420 kg of white flour, but they have used only 408. They should have used 140 of whole grain. They have used only 150. They have used more than that at 152. They should have used 9.35, but they have used 10. okay, of yeast. Okay, so if you see, when you are using more than the proportion, it becomes a, sorry, if you use less than the proportion, it becomes a favorable variance. When you use more than the proportion, it becomes a adverse variance, right? That's why these two are adverse. And what does the total adverse tell? The total adverse tells that that the total proportion of product, okay, this product is consuming more of, okay, is like it has crossed the standard proportion limits. Okay, it has crossed the standard proportion limits, and also it is using lot of costly raw materials a lot. So see, it is using a lot of costly raw materials, right? So it should have used only 9.35, but it has used 10. So it is using a costly material. 2.2 also is like costly only. When compared to 1.8 only, they are using less. A cheaper raw material they are using less, but a costly raw materials they are using more. So that will lead to more adverse variance. Okay, so we can put a suggestion. We can put a suggestion stating that the company uses more of costly raw materials and less of cheaper raw materials. Okay, also the company has moved away from the standard proportionate mix. So the company has moved from the standard proportionate mix, and also they are using a lot of raw material. Okay, the proportionately the raw materials like I think costly raw materials, I think we'll put it as, in bracket we'll put WG comma Y, they are using a lot, and the cheaper raw material is actually WF. So that they are using less. So we'll work out the yield variance. Okay, so to work out the yield variance, we need the numbers, so we'll put them here. So how does the yield variance work? So yield variance has a logic like this. The standard cost per unit, okay, SE refers to standard cost per unit of output, okay, so that's what SE refers to, into standard yield for actual input minus, so I think we are not getting that, one second, minus the actual yield. Okay, so that's about the concept here. So I think we'll show you the variance a little bit lower. I think now it is clear. So material yield variance you can work out like this. I think we'll put as material yield variance. We can put like this. So standard cost per unit of output into standard yield for actual input. Okay, what should have been the output for the input, for the actual input, and what is the actual output? Okay, so that's what we are trying to find out. So for this product, first we'll find out standard cost. Standard cost is very simple. So standard cost is what is the raw material cost of producing this product? That is very simply 1.34. So we got it very simply directly per unit. This is like per bread or per unit. So what about the standard yield? Standard yield is the company has put in some input. Okay, how much they have put? They have put 570.5 kg they have put. And how much does each unit take? Each unit should take 0.61. Each unit should take 0.61. So solve this, you will get the answer. So this is the number of units the company should have produced. This should have been the produced. Okay. So the logic is this: SY standard yield is the most difficult. Standard yield works like this: for the given input, okay, what should have been the output? So for 575.5 kg, they should have produced 935.246 units. But how much they have produced? They have produced 950. So 950 units, right? They have produced 950 units. So let's get the answer. Answer is like very simple. Once you get the numbers, it's very simple. So 935.246 minus 950. So the answer is like very straightforward, you can get. So the answer is 19.77 adverse. Okay, whether it's adverse or not, we have to find out. Look at here, it's very tricky. You should have produced 935 for the given input, but you have produced 950. That is, you are producing more. So is it adverse? The answer is no. It is favorable. So don't go with the symbols. Always don't go with symbols. Okay, look at the logic of it. Here it is adverse, but here it is, even though it is minus, it is favorable. Okay, so this is an output. See, all the other variances are input cost variances, but this alone is output variance. Okay, it is something like sales variance. Okay, so output variance, if it is negative, or sales variance it is negative, it is actually favorable. Okay, so that's about this sum. This sum, I think we'll put a suggestion. So suggestion is, the company has been efficient in producing the breads okay, I think that's enough. So the company has been efficient in producing breads. Okay, that is what our not suggestion, that is what our conclusion we can say. Okay, so what about the balance three questions? Okay, so that's what we want. So the balance three questions are: using the information in the question, suggest three possible reasons why an adverse material yield variance could arise. Okay, he's asking could arise only. It's not will arise. Okay, so we'll put it like this. Again, we will take the question downwards. So it put like this: reasons for adverse yield variance. Okay, so what can be the reasons? He's just asking for 1, 2, and 3 reasons. Okay, so first reason could be the production process begins with workers weighing out ingredients on an electrical scale. So that will not cause any problem in the outcome. Okay, yield is usually with the outcome. A worker then manually removes the mix from the machine. Okay, so manual as some mix is removed from the machine, it might machine some mix could be stuck in the machine itself. So that is one reason. So the second reason is, so some of the mix, bread mix is like stuck in the machine itself and shapes it into loaves by hand. Okay, as breads are shaped by hand, they could be uneven size. The sun size might be uneven. Okay, so next one is, after which the bread is then placed into the oven for baking. All baked loaves are then inspected by OBC's quality inspector before they are packaged. Okay, so quality inspector might be rejecting a few breads. Okay, that can be one more. And we can also say that some breads are over or under baked. Okay, so there is actually like 4 reasons. So we have took 4 reasons here. They asked only for 3, but we got 4. So hope this question helps you to understand the material mix and yield variance. Okay, we'll move on to the next problem. So this problem is also with respect to mix and yield variance. So we'll start.